Hi, welcome to the next step of the Puzzle Cube project, where we will make 5 multi-view drawings of your 5 parts. So one drawing for each part. So I take it back one step. You should have found 2 different ways to assemble a cube using 5 parts built out of our linking cubes to prototype these building blocks. Now, this is my chosen solution. I've done a couple, at least, and I've chosen this one to be the one that I'm going to build. So in the last step, we had made an isometric as well as our layered views. So I'm going to show you my purple piece as an example of doing a multi-view drawing. And underneath, you can see the finished product. So just to examine that in the end, you see that it's a multi-view. It has 3 orthographic projections, so straight-on views of the object, like so. I didn't trace this, but boy, that lines up pretty nicely. Okay, so we're looking at it from a perspective where we can only see one face at a time. So we get a front, a top, which is a 90-degree turn. Grab the top and pull it towards you to get your top view. Go back to the front, grab the right, pull that around, a 90-degree turn to get the right view. So we have 3 orthographic projections, and then lastly our isometric. And that is going to show 3 surfaces. We're going to get our front face, our right face, and our top face. So to get your block in the right position, grab the top and angle it a little bit, and then the right and angle the right side towards you a little bit. And according to your front, right, and top orthographic projections, this is the correct view of the isometric to make sure it matches your projections. So that's just going to slide right up here, and you're going to sketch that with the isometric paper. Okay? So first off, a couple details. Remember multi-view drawings. Your front and top should be aligned. Your front and rights should be aligned. We don't draw lines actually showing that they're aligned, they just are. Your extension lines for the dimensions almost act as that, if you will. They kind of help make it easy and obvious to see that they're aligned. But your view should be aligned nicely. And your extension lines, when you go to dimension this, do not touch the part. There's a little space left. And your dimension line, the line that the actual size of the part gets written down between, has arrows on the ends, and those arrows should touch, the very tip should touch the extension line, like so. Okay, so this is a nice example. Now, we covered a lot of dimensioning guidelines, and there's a couple I'd like to point out and remind you that this illustrates. One is that when we have a contour on our shape, we like to dimension the contour, as I did here with this 0.75, this 0.75, as well as this one, and up here. We always show the overall width, the overall height, and the overall depth. Okay, the depth of my object is from front to back, and when I pull this to my top view, well, that depth is now vertical here. So I show my 3 overall dimensions, width, height, and depth. Depth also could have been shown right here. That was a test question, guys. Then we have to show the smaller dimensions to make sure that we have enough to produce this part. Secondly, we have said that we prefer our dimensions to be in between the adjacent views. So as I dimension the width can be seen in the top as well as the front. I want those dimensions to be in between the 2. Even though they're only attached, the extension lines are only going to one view, I'd like them to be in between the 2 views that show width. And then height can be seen in both the front and the right, so I'd like the height dimensions to be in between those 2 as well. That's the preferred way if it's possible. But we do want to dimension the contours, and so sometimes we may find a part where we have to put a dimension outside, you know, over on the left side or the right side, or, you know, etc., maybe on the top. It just depends. But to try to minimize that, you want to take a second and consider your best front view. Out of these 4 pictures, which one do you think I should have drawn first? You can hit pause, think for a second. The one that you should draw first and consider first is the front view. The isometric, and really all of these, is determined from that one. So your front view, we've always said, should be the shape that helps us understand, or kind of gives us the best overall profile. And so this part, you can see it has, it's like a U shape with this extra block on the front. Okay? So obviously you can see what I chose. I want to take you back to one that, let's say I chose it first and I just made a mistake. I want you to learn from my mistake. Okay, sorry about the lighting. I'm in my classroom and the lights, if I don't move enough, turn off. Alright, well on this one, I started with the isometric. Okay, what I did is I saw that I've got this shape, and I knew that I wanted this to be the front face. I have this block sticking out. I certainly didn't want it to be behind there and be hidden and have to draw on hidden lines. So I knew I wanted that to be the front face. But what I didn't consider is the orientation. I've got 4 choices how I orientate it. Which one's best? I just grabbed one and went with it. I wasn't thinking very much. And in the end, you can see some work that I had to discard because I quickly saw once I got to here that I was going to have some problems, and I'll explain those. So I started with the isometric, and that isometric then determines my front and the orientation of my front. It should just slide down like this. This is going to be the front, this is going to be my top, and that's going to be the right. Okay? That looks okay. But if you remember the guidelines I just said about dimensioning, we said we'd like to dimension the contours. Well, when I go to dimension height, the contours are on the left. I also said that we like the dimensions to be in between the views. So if you picture the right view over here, when I go to dimension height, I'd prefer them to be here. But yet my contours are on the left. So I'm going to have to decide between which guideline do I follow, the contour or be in between. The reality is, you don't have to make that choice. Now, sometimes you might, and if you did, I would go on the contour first, but I'd like to get both. So that's one issue. There's another issue, and let's point that one out as well. The other issue is that, while I don't have any hidden lines here, when I grab the top and pull it up to do my top view, I'm going to have hidden lines. This is not a continuous depth from this point all the way back. So there is a change in depth, there's a change in the part here. So when I draw this top view, I'm going to have to use a hidden line right here to show that something changes. So that's a hidden line in my top view. Now consider my right view. When I grab the right side and pull that towards me, I have one flat, smooth surface, but that's not the reality of this part continuous to the back. There's a missing block here, and there's a missing block here. So I'm also going to have to show hidden lines in this view. Okay? So again, to summarize, I'm going to have an issue with dimensioning the height over here, as well as hidden lines in both of my other views. And there was a way around some of that. So if I pull back to my final solution, you'll see that from this position, I rotated it 90 degrees. These contours that are sticking out, I realize that if I point them towards one of the other projections, that then naturally, while I want to dimension them, will be in between those two projections. Also, in this view, if I grab it, lift the top and rotate it, everything is above. I don't have any missing blocks underneath. I'm not going to have any hidden lines. I do have some change in depths where I have to use object lines to show that this is not one plane on the surface, but I actually have 1, 2, 3, 4 planes. These two are at the same height, but they're separated. So I have 4 different planes that I am showing this transitions. So I have object lines, but I don't have hidden lines. And I prefer to keep my hidden lines to a minimum. Next up, when I go to grab the right side and pull it over, this contour is pointing to the left, so it's in between these two views, which is ideal. And I do have a hidden line here. Like you can see, this surface is not continuous all the way down. I have a break here, and so I am going to have to show a hidden line to show that something changes, as I did here. But that's only one hidden line, where before I was going to need hidden lines in both right and top views. and I was going to run into dimensioning contours outside, not in between the adjacent views. So you need to take a minute and consider not just what face is your front face, but what orientation is going to be your best. Then, before you take the time to draw, as I started to do, don't draw yet. Put this down and ask your neighbor, or at least one other person in your class, to say, hey, this is what I think is going to be my front view, this orientation. And let them consider the consequences of your top and your right as well. See if they can come up with a better orientation, maybe even a better face. Perhaps they'll look at it and say, why not use that as your front face? Okay? But just give them a chance to review it and give you feedback. So reach out and get at least one peer review on each part before you start investing the time in drawing. That is quicker than drawing this whole thing and realizing, boy, I really messed up. There was a much better way to do this one. Okay? Lastly, in terms of spacing, we don't want to draw these parts so little that I have lots of extra space all over my paper. So I'm trying to find a scale that simply seems appropriate and proportional to the paper and the space that I have to work with. Alright? So for me, it seemed that with all of these parts, they're either going to be 1, 2, or 3 blocks in dimension, any direction, because of our constraint of our puzzle cube. So using a 4x4 block on this graph paper seemed to be a good scale to represent one linking cube. And I would recommend doing the same. It makes it big enough that it's easy to draw your dimension lines and have room to write your numbers in between, but not so big that you don't have room and you run out of room getting close to the margin. If you start going bigger than that, 5, 6, depending on the part, you might run into some trouble. And making these too small, well, I really don't have at this point that much room to even draw both the dimension line and the dimension itself. So if you start making this too small, it's just hard for you to even write and keep it neat and organized. And then we're going to see lots of extra white blank space and wonder why in the world did you not utilize that space. So again, this is a technical drawing going to somebody who's going to produce the part. We want it to be reader friendly, just clear, neat, legible. Also, this is now a stage where you should be pulling out a straight edge or ruler and being more precise with your lines instead of a sketch. Okay? And lastly, I'll point out, you see all my dimensions. We should all have the same 3 numbers repeat in all of our dimensions. We're not putting a ruler on the paper and measuring how long this line is on paper. Our dimensions reflect the actual length of our physical object. So things on paper, they have to be scaled up or down to fit on the paper. But what we're telling you is how big this is in real life. And since these cubes are 3/4 of an inch, or 0.75 inches, you're either going to have 1, 2, or 3 blocks. You'll never have more than 3 cubes in one direction. So 0.75 times 2 is 1.5. And 0.75 times 3 is 2.25. Those are the only 3 distances that you should be using. Okay? So with that, good luck on making your 5 multi-view drawings.